Today, the content will be presented by Joel Odom, and he'll be walking us through building secure applications, followed by a customer spotlight with three of our colleagues from Coinbase, Kenneth Yang, Ishan Mundra, and Adrian Smith. Thanks.
Hi. So thanks for attending here. I assume everyone can hear me okay. Give me a thumbs up. Okay, good. Thank you so much for that. Well, as she said, I'm Joel Odom. I'm the staff product manager here at MongoDB for cryptography and encryption. So what does that mean? It means I cover our Atlas encryption features, like TLS features and our customer managed keys features. And I also cover Queryable Encryption. That's what we're going to talk about today. I'm real excited that today is the day where we finally make some new expressive query types available. I'll explain that, what that is. Let me start out by saying, though, some of the things we're talking about may be coming out in future versions of MongoDB. If I talk about those things, just be advised that make your decisions based on what we have in market today. So the first thing I want to talk about is different kinds of database encryption, because sometimes people don't quite understand what we mean by queryable encryption or encryption in use or full lifecycle encryption. So that's the thing that I need to set the stage about. I think most of us here understand pretty well encryption in transit. This is where we encrypt things as it's moving from node to node or from the client to the database. And it's really about making sure that we have TLS and a good TLS infrastructure throughout our ecosystem. So in Atlas, we have encryption in transit across the board. It can't be disabled, client to server, node to node, everything is encrypted in transit. And that's great, but really it only covers those hops from one computer to another computer as these massive MongoDB deployments are being used. The other kind of encryption we have is encryption at rest. And that's when the data is sitting on the database server and it's not being used. We have two different ways of doing encryption at rest in MongoDB. We have in Atlas volume level encryption, where all of the volumes of the physical infrastructure are encrypted. I think that's very well understood too, and that's table stakes these days for our cloud service. We also, though, in Atlas offer a customer managed keys feature, which is where you do file level encryption with your own keys. And that has a number of different benefits. It means the files are still encrypted while they're in backups. All's good. But what about data when it's actually in use in the database? So historically, this isn't something that has been well addressed by databases, because when we're talking about encryption, in a database, you've got to be able to do stuff with the data. What we're offering, though, with MongoDB Queryable Encryption is full lifecycle encryption. So it protects the data while it's in use, from the time that it leaves the client to the time it gets back to the client. And so it's easiest for me to illustrate that with an example. When you're using the database and you're using client-side encryption like Queryable Encryption, the database server, or the client sees all of the data just in its plain text form. So you can see all of the fields just like they're unencrypted. The client who has the keys can interact with those fields, can do everything it needs just like you're used to working with in a database like MongoDB. But because all of the encryption and decryption happens on the client, the server only gets to see what is either not encrypted at all, or the server can see what is only the ciphertext. And we represent that here as a bunch of stars. Under the hood, it's gobbledygook. It's a bunch of binary data. Not much can be done with it. And this is good for protection, because you know what? Your DBAs don't need to know Taylor Swift's social security number. Our date of birth is pretty well publicized, but it's encrypted too. So that information, the DBAs don't ever get to see it, though they can still administer the database and see the unencrypted data. AWS, if you're using for an underlying cloud service provider for on-premises or in Atlas, AWS can't get to the data. MongoDB, we can't get to the data. We don't want to see Taylor Swift's phone number. And it's going to be completely hidden in the database from us. And one thing that's interesting about that, if you think about it, is that we cannot be compelled by any force of law or finger breaking or whatever to go through and release the data that is stored in our database. We can be compelled to release the binary ciphertext, but that's going to be no good to anyone without the keys. So that's what client-side encryption brings you. But I told you that it's gobbledygook when it's in the database. So what does that mean for query, where the data has to be processed server-side? You could theoretically go say, all right, database, send me all the data, one record at a time, and I'll find the data that I need because I'm able to decrypt that data because I have the keys. But that's no good if you have a billion different consent records that you're having to search through for that one email address to get their consent status. So this is what Queryable Encryption looks to solve for. MongoDB Queryable Encryption, it's a one-of-a-kind technology. It's an in-use encryption technology which protects sensitive data throughout its entire life cycle. So it's stored securely in MongoDB, the DB database. It's protected as long as it's outside of your trust boundary. It's encrypted and protected. Yet we still allow you to perform expressive queries on that encrypted data. What do I mean by expressive queries? Well, we can do equality queries. And this is not a new thing. We've seen where you can do exact match queries on encrypted data if you use what we call deterministic encryption, and many of you are probably familiar with that. Queryable encryption, though, has a stronger security model. It performs equality queries on non-deterministically encrypted data. So if we put the same record in the database multiple times, it doesn't encrypt to the same thing each time. Range queries. So this is kind of neat. We have an encrypted salary, or let's say encrypted dates of birth, all in the database, and you may need to do things like segment your data based on the dates of birth of your prospects in the database, pull down only people who were born in between this year or that year, or on this particular date. You can do that, and you can query on encrypted data using range queries, or if it's financial numbers, you need to pull all salaries between some range, or all transactions in a banking system from 0 to some threshold. You can query on that, and you can perform compound queries. And today, we have just released in 8.2 as preview expressive query types that include prefix queries. So I'm going to demonstrate this in just a second. You can find all customers whose surnames begin with a certain few characters. Suffix queries, same thing. Last four of an encrypted social security number, you can query on that. And substring queries. So maybe you have a notes field or some free-form records that are encrypted because it may contain sensitive data. You can perform that query. So I'd like to jump right into the demonstration if I could. All right, well, we're going to switch over. So I got one or two slides. Here's what I'm going to show you for a demonstration of how this works. Suppose you're a hospital and you have a call center. And the call center reps, they need to be able to search when someone calls on the database, but in the database, it's all encrypted. So the architecture of the demonstration looks like this. It's a very simple architecture. It only contains a few boxes, but you can expand this to more complicated things. You have a trusted application server, and you have users who are maybe semi-trusted. You have some role-based access controls on that. And you have a KMS, all of which you control on the client side. And you want to store, the hospital wants to store the data in Atlas. What we want to do is we want to remove the need to trust Atlas with the data. So it's all encrypted in the Atlas database. So let me show you what this means by launching MongoDB Compass first. So I've set up this database. I'm going to show you the database, then I'm going to show you the actual demonstration. Let me expand this so people of all ages like myself can read it. And I'm going to connect to the database. Now, I'm running this locally. I didn't know if I had internet connectivity here or not. I'm running it locally instead of on Atlas. All you have to do is change the connection string to run it in Atlas. I'm going to go down to substring hospital. I've just got one collection in this simple little database. I've got a collection of 3.2 million records on my local database. So a lot of data. Clearly, you can't just pull all that down and iterate and see and find the record by doing an order of in search by pulling it all down. And in this case, I have encrypted everything. First name, last name, dates of birth, zip codes, and social security numbers. Great. So that is the encrypted data in the database. The demonstration, though, is going to be the call center app, and it's going to work pretty much just like you would expect. Let me tab over here. I'll reload it just for good measure. And suppose I call the call center. And they say, okay, your name, you said your name was Joel Odom. They type O-D-O-M. And then all of a sudden, almost instantly, all the records with my last name pop up. So that's pretty neat. And notice that it's just a prefix search. So I can do 3 characters, O-D-O, and I can see the O'Donnells as well. Something else I want you to notice, in case you didn't catch it, I typed lowercase for my last name, but in the database, the names are case sensitive. So we have also not only given the ability to do prefix search on first few characters of a last name, but we can do that with case insensitivity. And by the way, not everyone who uses MongoDB uses English, where we have very few accent marks and diacritics, but especially in non-English languages, there are multiple ways to represent data. We've done that. We've made it so that you can search with diacritic folding as well. So if data is represented with tildes or not tildes, or in German, the SZ versus a double S, all of that can be folded in for this kind of search. So it's fast and it's performant. It does kind of exactly what you would think. Let's look at the query under the hood. So I'll tab over to, why didn't that work? We'll give it just 1 second. Terminal. Okay, so there's my terminal, and you can see here, here's the most recent query that I just made. And let's see if that's big enough, I can expand it some. Yeah, so last name, prefix search, O-D-O, and that's it. But let's make the query more interesting. They say, all right, Mr. Odom, and can I get the last 4 digits of your social security number? Oh, well, that's 9999. So then, almost instantly, we've done a compound search, which now does a prefix search and a suffix search and combines it, and you've been able to almost instantly zero down on a single record. So that's pretty neat. I have other search types in this, though, too. So if I want to have a little bit of fun, I can look for all the Simpsons. And we've got a lot of Simpsons in the database, but I only want those Simpsons' zip code matches with equality 31415. And then instantly I can see, okay, there are a number of Simpsons here who live in this zip code. Year of birth, let's put in 1958. And then that is actually mixing in a range query, because I don't know if you noticed this, but in the database, the dates of birth are stored as dates of birth, but I have to query for an entire year, from January 1st of one year to January 1st of the next year. So let's just see what I queried on. There it is. It's a pretty big expression at this point. You can see I've done a prefix query, an equality query, and then a date of birth query with a range greater than and less than, and I've combined it all. That pretty much brings me to the demo. One other thing that I wanted to show, though, was here in Compass, you can see the encrypted data. Remember, the client controls the keys. So anyone to whom you give the keys, they can decrypt the data. So I can configure the MongoDB tools like Compass to see the data if I give it the keys, which I've done in this separate connection. Go down the substring hospital, open patients, and look, the data is exactly what you would expect it to be in decrypted form. There are a couple other things I want to talk about before we move on, and then I'll have a little bit of time for some questions. I often get asked about performance. The performance of Queryable Encryption, we made it with performance as the number 2 criteria after security and correctness. So it is performant. It all works in order of login-ish time, just like you would expect. This is a demonstration that I did where I set up on my home internet connection 1 laptop running 4 processes to a realistic cluster across the internet, an M63 node replica set, and you can see that the performance about 300 documents per second insert with what you see there for the different query types available. So that's good. Now, that's not 5,000 documents per second because we do have to create encrypted indices on that, but it's still performant enough for most of your workloads. And the query performance then is very, very fast. You may experience some milliseconds of latency depending on how you've built out the data model, but in this case I could still, from over the internet, find and query and iterate over and print about 5,000 results per second. Performance gets complicated if you have a lot of different query types, but you know what? Some customers, you only have 1 or 2 fields that you need to search on, but the rest you still want encrypted. You can specify a none query type, and then there's basically no overhead penalty for performance or for storage. And that's the last thing I wanted to talk about, was a little bit about the storage overhead. We do, all the queries themselves are encrypted, and we create on the database side encrypted indices. The encrypted indices, you pay a storage overhead for them, but you know what? It's like 2 kilobytes per document in this use case. So with 5.5 million records, 12 gigabytes, not a big deal. I was working with a major healthcare provider who's going to prototyping prefix and suffix queries and substring queries for one of their workloads that they want to move on to Atlas. They're required to encrypt the data client side before they can move it onto Atlas. They have 100 million records, and I calculated that for what they want to do, the encrypted indices would be about a terabyte. Terabyte in 2025, not that big of a deal. So that's the downside, is you do pay a little bit of a performance penalty and a storage penalty, but if with reasonable data modeling, that's reasonable for most use cases. So let me pause there. I'm going to take a few questions, and then we're going to kind of bring my colleagues on the stage. So how does Q&A work?
We're running you up a headset right now.
Here we go.
And then I will go and get questions for anyone that has them.
All right, thanks. We'll do a few questions.
Oh,
Now I can hear you.
can you hear me?
Now I can hear you now.
Okay, for PII data that needs this type of encryption, can we create encryption through tags or saying this is the data we want to be encrypted and how to identify it by role or how it's going to work?
Instead of, that's weird. Instead of, I don't like my own voice. Instead of telling you about it, let me show you. So this is the code. Now be careful, this code is available on the internet, by the way. I've published a lot on my GitHub, but take it with a grain of salt because it's demonstration code. But this is what it looks like. What you do, this is a Python example, but all the other drivers is pretty much the same paradigm. You lay down an encrypted fields map. So you can see here that I've got first name with prefix. I've said I want to index it with strings that are 3 to 8 characters, and I want it to be not case sensitive and not diacritic sensitive. So you go through and you can lay down other query types like range queries, and then I bound the date time. That lets me bound the index sizes. And then equality queries or no queries. I don't think I demonstrate that. And then I didn't demonstrate substring queries, but you can also lay down a substring. Yeah, I think we got can take a couple more questions.
Can you use your own encryption service, or is Mongo only like offering their own service with this?
Are you talking about a key service or an encryption service?
Key service.
Key service. Okay, yeah. So you can, but the key, we support all of the enterprise grade KMSs. So the cloud KMSs, AWS KMS, GCP KMS, Azure Key Vault, all supported. You can also use on-premises key vaults like HashiCorp if they support the KMIP protocol. And we also have what we call a local key provider, where that's what I'm using here, where you can just either, heaven forbid, for prototyping, hard code the keys if you want to, or we also have customers who are in production who actually use the local key provider. They write a sidecar process that injects the keys into it. So we support all of those key management systems. I think
Coming.
we got one up here.
For the data protection part, right? So in memory, how this is being prevented? Is it translated at the app level, or it's happening at the MongoDB level?
So the data is encrypted on the client side before it ever leaves the client. So the trust boundary is between the client. Well, the trust boundary is basically the client's network interface. So everything above the client's network interface is where the plaintext happens and the encryption happens. But before it leaves the driver to be sent out to the server on the network interface, the data and the queries are all encrypted then. So the only time the plaintext is ever exposed is in the memory of the client, then the driver encrypts it. Then once from then on, while it's in the database memory, it's never decrypted. Database disk, it's never decrypted. Whenever it's not on the client, on the wire, or being processed on the database, it is always being in use in encrypted form, and then it's only decrypted when the driver receives the encrypted data back from a query, and then it's decrypted there in memory. So, yeah.
We got a couple.
Yeah, can you explain maybe at least at the high level how you can query the encrypted data possibly? Because if it's random encrypted data, like each value will be different. I mean, how can you possibly query it by? I just don't understand it.
All right, you've asked a big question. I'm going to geek out for about 1 minute, then I'm going to invite my colleagues on the stage so we can catch up maybe afterwards. You and I can catch up. So the secret sauce is not in the encryption itself. The encryption itself is AES 256 in an authenticated mode, just like in CS school they'll teach is the good, strongest grade of encryption, the way it should be done against IND CPA and IND CCA attacks. So it's a good encryption. The secret is in the encrypted, I'll call them encrypted indexes. Now this is a scheme that was created by Cindy Kamara and Tariq Moataz, who are pioneers in the field of encrypted search. They started working on encrypted search back 15 or more years ago at Microsoft Research. They're from Brown. They're professor adjuncts at Brown University. Cindy is at least. So they're well published in this field. We acquired their technology and they joined our team, and I work with them on a weekly basis now. And the way their technology, and so it's published too. You can go to our MongoDB website and really geek out on it if you want. But the way it works is when the data is inserted into the database, we get some encrypted tags that come with it, and then the database server creates some encrypted indices. So then when the query happens, they're called encrypted multi-maps. So when the query itself happens, the client is then able to create more encrypted metadata. It's sent to the server, and then there's an algorithm where the server, without revealing too much information to the server in a blinded format, the server can query the indices, know which records to return, and return those records for decryption on the client. So, yeah, this is great. Thank you all for the demonstration. Now, I kind of want to pivot a little bit. We have some colleagues from Coinbase, and speaking of encryption, crypto is a big field. These days, we've got crypto in terms of cryptography, we've got cryptocurrency, and I think that the Coinbase and I would like to tell you a little bit about some of their work with cryptography, especially how they've done things like public key infrastructure and using short-lived certificates for authentication. So thanks for joining me. Let's start with, I'll give a little bit of introduction and then I'll let them further those introductions. So the reason I'm excited to be up here with Coinbase is because if you think about it, Coinbase has a huge target on their back. Think nation-state actors, the biggest ones you could possibly think about. So they hold in assets almost $500 billion of assets, so approaching $500 billion of assets. Their quarterly trading volume, I took some notes here, is almost $240 billion per quarter traded in cryptocurrency. So can you imagine, if you've got that much cryptocurrency under your control that you shepherd and manage for your customers, you've got the nation states who are in the news going after you. You absolutely have to have the best and highest grade security. So Kenneth, I'm really glad to have you on board with your team here, and I was hoping maybe y'all can do some introduction of yourselves.
Yeah, absolutely. Thanks so much for having us, Joel. Really happy to be here. My name's Kenneth, this is Ishan, and this is Adrian. We're all software engineers on the security team under key management right now. So we're really looking to build these kind of like paved road for different key management solutions, and we specifically focus on public key infrastructure.
Great, thanks. So yeah, I was talking with y'all earlier. I was really impressed by the way that you're using short-lived certificates throughout the Coinbase infrastructure to do all kinds of different things, and we'll get there. But one thing that I was curious about, given that Coinbase has just as big a target as any of the major financial institutions, if not bigger, given that you're trading in cryptocurrency, tell me some about your company's general approach to security. Like, do they have to keep everything behind 6-foot steel doors with machine guns, or how do you keep that much cryptocurrency safe?
Yeah, absolutely. I think that's a great question. I think that a lot of our philosophies, and this is a personal philosophy as well, but I think we really need to enable developers to move fast. When it comes to security, you don't really want to say, hey, we're kind of gatekeeping, we're preventing you from shipping fast. But at the same time, you really want to create these paved roads so that people have the tools that they need to not worry about security, right? So in our specific case, we really want to create these platforms, key management solutions, where developers don't really have to worry about how PKI works or how secrets management works. If they need some type of certificate to do authentication or code signing or whatever they need, it just kind of works for them underneath the hood, right? So that's kind of the goal for our team, just kind of not be a blocker, but rather an enabler for our developer teams.
So a reduction of friction whilst making it easy to be secure. What it sounds like.
Yeah, absolutely. I think an analogy is you want to give them the tools. You don't want to give your developers a butcher's knife. You want to give them a butter knife so that they can do their job, right? So something like that.
So when we were talking earlier, you were telling me about your move to short-lived certificates, and that's a big thing in the industry now. I know Let's Encrypt is doing that. Colleagues and I talked to them. We're looking at increasing our TLS posture in MongoDB, but certificates are used for a lot more than just TLS, and I think that you're using them for more. Can you expand on your use cases and let everyone know just how this project that you have in mind, all the use cases for it?
Yeah, I can talk about this one a little bit. So as Kenneth just mentioned, our general philosophy is to try to get as close to a zero trust model as we can. So this plays a part, especially at a lot of the boundaries in our organization. So when services are communicating with other services or humans are trying to interact with services, this is where short-lived certificates and ephemeral key material in particular will come in super handy compared to traditional methods of authentication like username and password. So just a couple of examples of recent things our team has been working on. We've been using certificates for service identity. So when services start up and they need certificates to establish TLS connections, they'll reach out to our internal CA. We've also started to use it for signing purposes, so package signing, container signing. Basically, anytime we want to validate that some software artifact within our organization did actually originate from trusted build systems, we can use certificate-based signing for those approaches as well. And then recently, we've been leading an initiative actually around MongoDB with authenticating to MongoDB as well as other third-party tools, but using certificate-based auth with these short-lived certificates rather than a long-lived username and password, which can potentially get compromised or can be used beyond the lifetime that it's originally intended for.
Yeah. So I know our PM for IAM is in the audience, so she may be more interested in that particular use case, especially. At some point too, let's not do it now, but I kind of want to geek out on how you use short-lived certificates and code signing, because I know that that's always kind of a tension. But yeah, so there are short-lived certificates, because they are rotated frequently, and you have to issue or reissued frequently, let's say. And you're using them for all of these different use cases, including MongoDB authentication. How do you deal with scale? Coinbase is not a small operation anymore, so the scaling of this has to be a real thing.
Yeah, so I'll talk about this one a little bit. we issue around 200,000 certificates a day. All these are short-lived, and we can't directly issue these from AWS private CA because there's lifetime quotas of 1 million it's just 1 million actually. And that means that we need to basically figure out a way to solution around this. So what we've done is, instead of directly calling and essentially proxying AWS private CA, what we do is we issue subordinate CAs within our internal CA, and those subordinate CAs are responsible for issuing end entity certificates. So this enables us to scale to upwards of 200,000 certificates issued per day, which is something that we saw logged, I think, on our metrics last week. And also, one important thing to note is that key material is never stored in memory. So key material is only really ever where it should be, which means that we don't ever have to transmit it anywhere, keeping things secure as it possibly can be.
Nice. So I didn't know about the 1 million lifetime certificate you use AWS, right?
Yeah.
So do me a favor, when you reach 990,000, let me know, because I want to cash out my cryptocurrency right there.
All right, sounds good.
But regarding scale too, so obviously trust in your infrastructure from your customers and from your developers. You have to keep your business running 24/7 with 5 nines. Can you tell me more? Then we've talked about scale. What about high availability? How do you make sure that these certificates are there when you need them before they start expiring and everything comes to a crawl?
Yeah, absolutely. I think that's a great question. And I think this comes down to trade-off at the end of the day. It's whether you want to have a synchronous process for issuing these certificates, which we do, versus if you want to have some asynchronous process or some orchestration flow where you say that hey, maybe I'll issue these certificates for a year, but then after X amount of months, I'm going to rotate it out, right? So with a synchronous approach, you really have to ensure that you do have extreme high availability, and you have to think about fault tolerance from a distributed systems point of view, right? So things that we put in place, right, is we really introduce multi-region for pretty much everything, right? Our upstream certificate authorities run in multiple regions. Our database clusters, they run in multiple regions as well. But even on top of this, right, there's additional circuit breakers or break glass scenarios as well, where let's say that 2 regions go down and there's just a complete outage for whatever reason, right? There's still disaster recovery scenarios that you have to put in place just to make sure that the business is still able to continue, right? So just some things to think about.
Yeah, so we talk about the CIA triad, not the intelligence agency, but confidentiality, integrity, and availability. And so I think sometimes customers don't appreciate the need for availability. There's a trade-off. What I'm trying to say is there's a trade-off between availability and security. So if I understand correctly, you do have break glass capabilities to where you can, in that scenario, short the security controls and keep the business running while you reestablish that.
Yeah, absolutely. And the whole idea is you're able to issue these key materials dynamically in memory, right? So whenever a service starts up, a key material gets issued locally, and then we're able to sign the CSR to get you a certificate chain. But the thing is, maybe in that pattern, your key material never leaves the client that it was generated on. But there might be situations where, okay, let's say that our system's completely offline. We do have ways to kind of issue these long-lived ones to put it in our secrets manager, where the clients can then pull it down. So that's again a trade-off where you're saying, hey, in these disaster scenario situations, you're putting these in some secrets manager and pulling from there, which might be acceptable, right? But that's kind of not the ideal solution that we want in the most case.
Speaking of scale then, for this kind of, it's a synchronous solution, is performance really a thing, or is it that certificates have enough longevity in them that, how much consideration when you were building this did you have to give to performance? Let me put it that way.
Yeah, performance is a huge concern for us. Since we're in the critical path for a lot of services, for example, during server startup, we want to have low latency responses. And yeah, we talked about scale, we talked about availability. I feel like those are two. Performance really comes into context with these other considerations. You can have the most performant system, and if it's servicing 10 requests per minute, or if it's only available some portion of the time, it doesn't really matter. So, but performance is definitely something we think about a lot. Sometimes we have upfront requirements. Like Adrian mentioned, we know that our system needs to be able to service, even before it was designed, and we knew it was going to need to service tens of thousands of requests at some point. But those will continue to evolve. We didn't necessarily know or design it upfront knowing that we would hit 200,000 requests per day. So it's kind of a constant constant battle or constant journey, I'm sure with most engineering teams out there, of triaging and figuring things out on the fly. We had one like we lead investigations all the time and like talk with internal customers as well. We had one case recently where another team at Coinbase was encountering issues with requesting certificates at startup time. So we went in and actually looked at how they were making these requests and like what kind of generation they were doing on the client side. And for them, it was a case of like they were using RSA keys instead of ECDSA keys, and it was just it takes longer to actually find those primes to actually generate RSA keys. So we had them swap the algorithm there and make a couple of other small changes, and that helped solve their use case. So it's kind of a interesting like journey that we go on, where sometimes we'll make changes on our side, like on the server, and we'll like change authentication patterns or make modifications to things that can obviously cut down on the total amount of time it takes for us to service a request. But also a lot of times it'll be optimizations that we can make for individual use cases for different teams that have intensive workloads.
Yeah, I love it when you say primes and RSA. So I've written down a 250-digit prime here. I want you to let me know if it's prime or not. I'm kidding. And one thing too about performance, I expect it's going to be kind of bursty. Like if everyone shows up at 9 a.m. on Monday morning and starts working, and all their old certificates are expired, 200,000 a day, you might do like 100,000 in the first 2 hours. Is that?
Yeah, it's honestly more linked towards, so the human component of it does increase load. Like people will come in and request certificates for authenticating to different like third-party tools or things across our organization, but a lot of the certificates end up getting used in services. Like that's the vast majority of our workload, so it'll be linked to things, some of which will line up with a working day, like service redeployments, but sometimes it'll just be like services will request them under the hood throughout the day. So we do see bursts, but it's not as concentrated as you might expect.
Okay. What about when things go wrong? Like in particular, I'm thinking about revocation. That's been talked about for decades, certificate revocation. Is that a thing?
Yeah, absolutely. That's a great question. So when it comes to revocation, like for short-lived certificates, it's actually really difficult to do revocation. And the reason for that is because a lot of times the subordinate CAs that are signing these end entity certificates, those private keys are actually short-lived. So what that means is, like, in order for you to actually sign a revocation request, you actually need to use the same private keys that issued those certificates. But if the subordinates are short-lived, then it might go away, right? So there's a trade-off. If you want these, like, this pattern of using short-lived certificates, then maybe revocation might be really difficult for your use case unless you want to keep those keys around, right? But in certain scenarios where we have these like break glass solutions, right, where we say, hey, we're going to issue these like long-lived certificates because let's say there's a complete outage in like a bunch of our cloud infrastructure, then in cases like those, right, then we're issuing it directly from our upstream CAs, and we do support revocation for those, right? So I think again, this comes down to trade-off between like what you actually need. So
yeah, this is interesting to me because as the PM for crypto at Mongo, we've talked about like what are we doing now, that OCSP, the Online Certificate Status Protocol, that's not really a thing anymore. It sounded like a good idea 10 years ago and it turned out not to be. And CRL, so yeah, short-lived I think is the way to go, and it kind of gets rid of that whole notion of needs of revocation.
Yeah, 100%. And talking about revocation as well, like you could like technically sign a revocation request and say that like, hey, this certificate is revoked, but unless your server actually checks it, nothing actually happens. So a lot of the revocation, it also depends on kind of like the implementation on the other side as well.
What about challenges, lessons learned? I mean, what would you like these folks to know about the interesting aspects of the journey?
Yeah, so definitely some of the challenges that we had were just meeting SLAs in general. I think like this service, since as we mentioned before, this is a critical path for a lot of different services throughout the company. That means we need to be online all the time, and maintaining this service with just the three of us can be challenging. But our uptime is really good as it stands right now, so that's a good thing. But second to that is also, like we mentioned before around bursting, like we're actually rolling out X509 authentication to all the Mongo clients across Coinbase right now, and we're noticing that onboarding can be a pretty administrative, a complex administrative task to get all these people onboarded and to get their resources set up properly. So we've utilized Terraform, we've also utilized sharing cursor prompts and AI prompting, and sharing these so that we've been able to essentially speed up the process and get people onboarded, get people understanding the documentation and able to issue their certificates as they need to in order to access Mongo.
Can you estimate how many people worked on the project to make all that happen?
So migration is a very interesting topic. I think that because it's like an entire company-wide migration, it's not something that like our team is going to do for everyone, of course. So in our particular case, like we aligned with leadership and said like, hey, like everyone needs to get it done by this particular date. We provide them all of the self-service tooling in order for it to happen. But if there's any blimps along the way for kind of customers onboarding themselves, then they can reach out to us, and we're kind of like a help desk essentially. So, but yeah, unfortunately, we don't have the capacity to migrate the entire company. So.
Got it. Understood. Well, I know that Coinbase is one of our star customers. So much of what you do is powered by MongoDB, and we're glad you're using this for authentication. But just kind of taking a step back, what are y'all looking forward to coming out of MongoDB in the future?
Yeah, actually, like I really love the presentation today on Queryable Encryption. We actually do something very similar with an in-house solution for some of our like data warehouses. So I think in a lot of cases, like it makes sense to build custom solutions, but if there's other like managed solutions from like cloud providers or like other third-party vendors that do kind of like the same thing, or if not better, I think that that's something absolutely worth exploring, especially if it's kind of like these like security-centric like products as well, right? So I think that Queryable Encryption is absolutely something that like I would personally be very excited to kind of like dig more into.
There you go. Thanks for the plug, and I'll get your Venmo after we're done.
Sounds good.
All right, well, thank you so much for coming up, y'all. I appreciate it. And that ends the session. We'll turn it over. I guess, well, why don't we take a few minutes for questions? We got about 3 minutes left. Why don't we do that? Well, tell you what, we'll be here all, I think, for a little bit after the show. So thank you all for coming out, and we'll see you around. We'll be here for questions.
Sounds good. Thank you.
Thanks.